Okay, so here we have a triangle ABC, and we can move the vertices around the screen, changing the lengths of the sides of the triangle. We're also changing the angle. So when I move this point around, all three angles are changing. Two of the sides are changing length. And if I want to change the third side, I can move this point. This is not a right triangle. There's no right angles in this triangle. So here we have an expression where we've taken the sine of the angle A and divided it by the length of side A. So you'll notice that angle A is across from side A. And this is a ratio. However, it's different than the trig ratios we were talking about previously. Okay, so this is sine A divided by A. And if we calculate that for this triangle, the angle is 55 degrees and the side length is 4.3. And if we use our calculator to find sine of 55 and divide it by 4.3, we'll get this number. Now, why is this number useful? So you can see that as the angle gets larger, so does the side. And if the side gets larger, the angle is getting larger as well. Let's do the same thing for angle B and side B. So this is side B here because it's across from angle B. And when we calculate that ratio, even though the angles are different and the side is different, we're getting the same quantity, even when I change the angles and the sides. Look at the third side and angle. We see again that it's equal. Now, this is an interesting property that we can use to solve triangles. And let's see how that works. So here we've got another triangle called ABC. And we saw that this ratio is equal to this ratio is equal to this ratio. So let's see if we can use that to solve this triangle. We have side B and angle B. We don't have anything about angle A or side A. So I'm just filling in all the information I have. And we don't have side C, we're actually looking for side C. So what I'm going to actually do is take this here, and just looking at that equation, I can see that there's only one variable. And because there's only one variable in this equation, I know that I can solve for that variable. I can isolate for that variable. So what I'm going to do is multiply both sides by C. And I'm trying to isolate C, so I'm going to multiply both sides by 32. I'm not evaluating sine 40 yet or sine 60. I could, but I'm gonna leave that to the end. To isolate C, I've got to get rid of this factor here, and I'm going to divide both sides by this amount. Now that I have CL by itself, I'm just going to crunch all those numbers all at once. Let the calculator do the hard work. .8 centimeters. Let's try this again. This time we're going to use it to find an angle rather than a side. So what are we given? We're given the side C. We're given the side B. We're given the angle B. We don't have any information about A. Angle A or side A, that is. And we're trying to find angle C, so that's a variable. Now I have two variables here which are not going to help me. I'm not looking for those. I'm looking for C. So I'm going to grab these two ratios, make an equation out of them, and that's what I'm going to use to solve for C. So just like before, I'm trying to isolate C, so I'm going to get rid of this 35 by multiplying both sides by 35. And this is the sine of C, which is a ratio. It's not an angle, but we want to get the angle. So to do that, we're going to take the inverse sine of both sides of the equation. So I take that whole thing, put it in inverse sine, and then that is my angle. So on my calculator, I'm going to start off with inverse sine. We use the brackets. And I get 37.3 degrees because it's an angle. Okay, so we've got a triangle to solve. We'll do A first. And so we have information about the angle B and the side B. So sine of 62 degrees over 70, and we can equate that to the information about side C and angle C. Angle C is 43 degrees. This is going to allow us to get side C. So then we'll have the third side. Multiply both sides by c. And I'm going to multiply both sides by 70. And divide both sides by 62. Sine 62 rather. .1 centimeters. So we have two of the sides, and we want to find the third side. We need to get angle A as well. Angle A is just going to be 180 minus 62 minus 43, 75 degrees. So we've got side C, angle A. What's left? We've got to find side A. So sine of A over A is equal to the sine of angle B over side B. So we can do sine 75 over A we want to isolate for A. So I know I'm going to have to multiply both sides by A, and then I'm going to have to multiply both sides by 70. I'm going to do both of those in one step. And now I'm going to divide both sides by sine 62. And for my A value, .6. So I've got a side, angle, another side, and I've solved that triangle. So to do B, I've got an angle and a side that goes along with it. And I have a side, and I'm going to find its corresponding angle, which is angle Y. So multiply both sides by 9 and both sides, sorry, just by 9 to give me sine Y. And then I'm going to take the sine inverse. we get y. .6 degrees. So I've got two angles. Easiest thing to do right now would be to find the last angle. So that last angle is Z. It's 180 minus 65 and minus 35.6. $79.4. Got two angles, two sides. The last side is side Z. Small z. And I'm going to use the information about x. I'm going to multiply both sides by z and both sides by 14. Divide both sides by sine 65. .2 centimeters. And there we have our triangle solved. We have three sides and three angles. Two ships are located 15 nautical miles apart. Alpha's angle to the entrance of the port is 55 degrees with respect to beta. Beta's angle to the entrance to the port is 45 degrees with respect to alpha. Which ship is closer to the port entrance? How far is the ship from port? Round your answer to the nearest tenth. So we've got two ships and we have a port. We'll just call this A for alpha, B for beta, P for port. And this forms a triangle, which we can take angles of. So alpha's angle to the entrance of the port with respect to beta, we're talking about this angle. And similarly, beta's angle to the port with respect to alpha is 45. So we have this situation. The other piece of information we have is their distance apart. So we've got two angles and a side. Whenever we have two angles, we really have three because the third one can be found quite easily. So angle P in this case is going to be .80 degrees, so we can add that to our diagram. Now we have an angle across from a side, which is useful. Now we could go ahead and we could solve both of those sides and figure out which one is smaller, which chip is closer to the port. But if you remember and you were listening carefully earlier, I said that when the angle is smaller, we have a smaller distance. So because this angle is smaller than this one, we expect this distance to be less than this distance. So I'm not even going to bother calculating this one. And I'm just going to find this distance. This is true because we have an acute triangle. All the angles are under 90. So this is side small b. I'm going to go ahead and find that. Okay, doing a little shortcut. And dividing both sides by sine 80. I get 10.8 nautical miles.